This is the video of the Unit 11, Section 3 notes. Our objective today is that we're going to use a distance formula to find the perimeter. We're also going to use it to determine what kind of shapes things are, whether they're rectangle, rhombus, square, that kind of stuff. So we're going to use a distance formula. Hopefully all of y'all remember this. We have 2 points, and one of our points will be x1, y1. There should be a 1 right here, and the other one should be x2, y2. So first it asks us to find the distance between A, which is -1, 7, and B, 4, -19. So I'd like to label these x1, y1, and then plug them into the formula. So when I do that, I plug in 4, which is my x2, and -1, which is my x1. Remembering that when I've got 2 minus signs next to each other because the formula has a minus in it. Then we're going to do -19 minus 7. Again, y2 minus y1. We're going to simplify this here, so when we add this, when we change the sign, because we have 2 negatives together, it becomes a positive. When we have 4 to 1 and -19 and -7, we get 5 and -26. We're going to square those two terms, and then we're going to add those together. That gives us a square root of 701, and that is equal to 26.48. Now what I want you guys to remember is Pemdas, because in Pemdas we do what's in our parentheses first, then we do our exponents, then we add, then we'll do our square root. So that's our order of operations, and that's really important to this unit, and to this section, sorry. All right, so our next one says quadrilateral ABCD has the vertices of A, B, C, D. So on these, if you have a grid, you can plot it, but if you don't, then you can at least draw yourself a shape that is a quadrilateral, A, B, C, D. And the reason I like to do this is because it helps me determine what the sides are. So I have side AB, and then side BC, and then I have side AB here, I have side BC here, then I have CD, and then I have DA. Also, I notice here that I have opposite sides. AB and DC are opposite sides, and AD and BC are opposite sides, and that's going to become relevant as we work through the problem. So I'm going to go ahead and label these points right here that I have put onto my grid, because we may come back to this. And I'm going to go ahead and draw this shape. So that's what our quadrilateral would look like if it was on a coordinate plane. So now it says what we need to do is find the length of every side. So we're going to use our distance formula to do that. So we're going to plug our values in for A and B. I'm always going to put my second point as my x2, y2. When I add 3 to 2, that's 5. When I subtract 2 from 2, that's 0. Square the 5 here. That's going to give me 25, and the square root of 25 is 5. So that's my AB. Going to do that for all the rest of the sides as well. So if you're working these out, go ahead and pause the video and solve for BC, CD, DA. So the next one I did was CD. And the reason I did that is because it's the side opposite of AB. 1 minus 6 is -5. 2 minus 2 is 0. Again, anytime I square a number, we need to recall that any number squared is a positive number. So I get 25 plus 0 again. Square root of 25 is 5. So now we know that at least one pair of these opposite sides is congruent. So now let's go ahead and solve for BC and DA, or AD. So BC, again, plug in my values in here. Go ahead and check your answers. Make sure that you haven't gotten anything in the wrong place. Remember that when we have a minus, it turns to a plus. So 3 squared is 9, and 4 squared is 16. Add 9 to 16, that's 25. So we have a third side now that is 5. So our first 3 sides, A, B, C, D, and BC are all 5. So we got one more left to solve for, either AD or DA, doesn't matter which way you do it. So go ahead and plug in your values again. Notice again we have minus and minus here, so that's going to be plus. Minus and minus, that's going to be plus. So that's going to be 3 right here and 4 right here. 3 squared, 4 squared. That's 9 and 16. Again, that's 25. So notice that we have all 4 sides that equal 5. So We know for sure that this is a rhombus because the definition of a rhombus is it has 4 congruent sides. So we can say for sure that it's a rhombus. All 4 sides are congruent, so it's a rhombus. Now, we want to also compare the slopes of AB and BC because a square has also got 4 congruent sides, and we want to be able to compare the slopes of a pair of sides to see if it produces a right angle. So when I compare the slopes of AB, the slope of AB is 0, and I compare it with the slope of BC, the slope of BC is -4/3. Well, if this was 0, this should be undefined because we couldn't divide by 0, but that's not the case here. So we know for sure that this is just a rhombus. It's not a square because the slopes are not perpendiculars of each other. And when we have right angles, it produces perpendicular slopes. So not perpendicular slopes, so it's not right angles. So again, it's just a rhombus. All right, so now this problem here says, given that M and PQ is a rectangle with vertices M, N, and P, find the coordinates Q that make this a rectangle. So I like to sketch these first so that I, again, can pick my pieces that I want to use to be able to solve this problem. So what I'm going to do first is I'm going to draw a diagonal here from M to P. And when I do that, I want to go ahead and find that midpoint there. Because if I can find the midpoint of that diagonal, then I can use it to solve for my endpoint Q up here on the other diagonal. So the very first thing we want to do then is find the midpoint of segment MP. To do that, we add our x's together, divide by 2, add our y's together, divide by 2. And when we do that, we get 9 divided by 2. And that's -3, and that's the x value, and then -3 over 2 is the y value. So then this is our x and y value of our midpoint. Now what I want to do is I want to solve for the other endpoint. So I'm going to now draw another diagonal here. Now this diagonal, I have the midpoint now. That's going to be 4.5 comma, I'm sorry, 4.5 comma, -1.5. That's my midpoint. Now I have an endpoint and a midpoint, and this kind of goes back to the lesson that we did on Friday. So now what we're going to do is we're going to plug those values in. We have the endpoint. We're going to find the endpoint of NQ. So here's our x value of our midpoint, and that's our n, x value of our n. Multiply both sides by 2. We're going to subtract the 1. So our x value here is 8. Do the same thing with the midpoint. So we got -1.5 equals -6. That's again the y value of n. We're going to add it to our endpoint, divide by 2. Going to multiply both sides by 2 here to get rid of the 2 in the denominator. So when we do that, we get -3 is equal to -6 plus y. We're going to add 6 to both sides. So now our point Q is going to be 8, 3. So point Q out here would be 8, 3 of this rectangle. So your steps again are to find the midpoint of the given diagonal and then use that midpoint with one of the endpoints to find the other endpoint. All right, now I'd like you to try the problem at the bottom of the page. Go ahead and again, I always draw the shape. Now it doesn't have to be exactly like the shape should be, but it needs to be some semblance of it so that I can figure out what my sides are, WX, XY, YZ, and WZ. I also like to do this because then I can compare opposite sides. So XW and YZ are opposite sides, XY and WZ are opposite sides. So we need to find the lengths of these sides so we can determine what kind of shape this is. So when we find WX, again, we're going to put our points in. This is going to be the square root of 20. Now I can go ahead and do that one more step and it would end up being 4.5, but I don't really need to here because I'm just comparing the lengths of sides. So then we're going to find the opposite side, which was YZ. Again, plug your points in, and we get the square root of 20 here as well. So now we know that a pair of opposite sides are congruent. So now we need to find XY and WZ. So XY, when we plug our values in here, we get that XY is 5. So now let's check WZ. WZ, again, when we do this one, we get 5 as well. So when we look at this problem, We know that wx is square root of 20 and xz is square root of 20. So let's go back and again draw this again because I think it'll help you guys to see this. Wx, y, and z here. So wx is the square root of 20 and yz is the square root of 20. And then we've got these other two sides are 5. So we know that at the very least, because opposite sides are congruent, that this is a parallelogram. Now let's check and see if it's a rectangle. Now the way we would determine if it's a rectangle is we would find out if wy and zx are these guys congruent? Because if those are congruent, then we can say this is a rectangle. So let's check wy. When we do wy, we get square root of 65. When we do xz, we get the square root of 25. So square root of 65 and square root of 25 are not congruent, so the diagonals are not congruent, so thus it's just simply a parallelogram. Alright, so we're on the back of the page now. Perimeter is the distance around the two-dimensional figure. So basically we add up all the sides and that's the perimeter. To find the perimeter of a figure in a coordinate plane, we're going to use the distance formula and add all the segments together. Now, on your notes, it says to do go back and look at example 3, but we're going to look at example 2 instead, just for the speed of getting the problem done. So we had that AB was 5, and CD and BC and AD were all 5. So to find the perimeter, we just add those 4 things together to get our perimeter, and our perimeter would have been 20. All right, so this next one, it says find the perimeter of LMN, where L, M, and N are the various points. Now, when we do this problem, again, you should see very quickly that this is a triangle. So we're going to find the length of side LM. That is 4.24. We're going to find the length of MN. That was 3.61. And then we're going to find the length of LN. And that one is 6.08. Now what we're going to do with these 3 sides when we're looking for the perimeter is we're just going to add those together. That gives us 13.93. Now the next question on y'all's paper says, is there a way to classify this triangle? And if so, what type of triangle would this be? Well, the first thing I would do is see if it's a right triangle. So I would do 4.24 squared plus 3.61 squared and compare that to 6.08 squared. Well, when I did that, I didn't get that it was equal. Thus, I know it's not a right triangle. Now, I could also use that to determine whether it's an acute or an obtuse triangle. The angle is, but we don't need that. If it was an equilateral triangle, all 3 of these sides would be the same, so we can eliminate that. If it was isosceles, 2 of these sides would be the same, and that's not the case either, so it's not isosceles. So it's not equilateral, it's not right, it's not isosceles. So our only choice here is because it has 3 different side lengths, it means it's a scalene triangle. All right, so now I want you to do this last problem. Go ahead and find, again, the length of every side and then add those sides together. So you're going to use the distance formula 4 times for Wx, Xy, Yz, and Wz. Go ahead and do that and come back to me when you're done and we'll check the answer. Okay, so Wx, when we do it, we get 3.61. Xy is 5.39. YZ 6.71 and WZ 6.40. Now to find the perimeter, which is what we're being asked here, we add those 4 lengths together. When we do that, we get 22.11.